Good morning, guys. So today's webinar on deep learning in NLP. So we will start by giving an introduction to what we are actually going to see. What's the agenda for this particular webinar, and how are we going to understand what is happening in the industry. And there's a separate session for understanding the career path, followed by question and answer session where I will be able to answer questions by all the attendees. So, this is the agenda. Initially, I'm going to give an introduction to deep learning, and then followed by something very specific in the space of NLP. And the third one, is something which is very important, where I will talk about the different components of deep learning, followed by a case study. And then, as I said, we'll discuss on what is the kind of career path in this particular space, and then I can answer all your questions. So this is how I have structured the webinar. So feel free to ask the questions. Anyway, we will have a good discussion at the last. So to start with, now let me answer the first question: why deep learning? So traditionally, we have been using machine learning techniques to solve multiple problems, different use cases, different sets of issues occurring across multiple industries. Now, as we grew up, we also found that the data is huge, and there are a lot of other difficulties, such as features need to be selected appropriately, and we need to handle the huge amount of data in a really smart way. So that is when deep learning came to the rescue. There are a lot of approaches to the same problem using deep learning, but the fundamentals are going to be the same. Let's say if I'm going to build a deep learning architecture for solving a particular problem, the basic steps are always going to be the same. Particularly in NLP, it is kind of you will have the following steps, and just the architecture will change according to the different use cases. Now, where we use deep learning, and what kind of mechanism is it really about? So, as I said, deep learning is essentially a subset. It isn't the vast field, but deep learning has the most importance currently, because the capability and the ability to solve a problem is enormous using deep learning. Now, in order to give a quick introduction and where to start kind of scenario, I have put down some of the tools which are available freely in the market. And again, this is not limited to. I have given down Keras, Tiano, Torch, but there are more and more. So you can use OpenCV, you can use other tools also. But essentially, all the algorithms which are going to work on top of these, any of these tools are going to be the same. Let's say if I'm going to build a deep learning model using LSTM, it is kind of going to be similar when I talk about the approach. Just the syntaxes are different according to different deep learning frameworks. And again, each of these frameworks have their own advantages and disadvantages. Some of them handle really smartly the huge amount of data. Some are built specifically for let's say image based approaches, and stuff like that. Now, if I want to talk about the key focus areas in deep learning, so these 7 are some of the top focus areas. Again, they are not limited to these 7 alone, but these are the most happening places. IoT, as you guys are aware of, I think I did cover some of the concepts of IoT in the last webinar. IoT space has a lot of potential, and we use deep learning to crack some of the problems which are occurring. Now, self-driving cars, you might have heard about this enormous number of times. Google does, Tesla does, all the other companies have started venturing into, and some of them have achieved a really good improvement in this particular space. Voice recognition, again, one of the happening areas where I tried to recognize some of the voices and generate text from those voices. Speech generation. Now, speech generation is something I would say a vice versa of voice recognition, where you take an input and give an output. So again, the output is also in the form of voice. Now, the reason they do that is, if let's say if I'm having a chatbot where I need to read all the text, whereas there are some of the chatbots which are coming up where it speaks out directly to the user. So that makes the user feel really close to that particular issue or getting it solved, and hence the customer experience is slightly better. Machine translation, again, this is something which is I would say in research and in development mode, where they translate different languages to target languages. Text generation, this is something like, let's say if I give you a text and ask the model to predict, just give me a caption for this text. So that is where text generation is involved. Again, this particular text generation of late has achieved really good potential, and people have done really smart work, and the the improvements are quite good. Video analysis, I think video analysis is something you might have come across a module called YOLO. Of late, that is something which is very good, and you can find that video analysis is being used in tracking traffic related issues. Also, some of the video related are mostly into geospatial understanding, where they track what kind of changes in climate are happening, and so that those are again some of the most happening use cases. Now set the introduction of what is deep learning, and what we will be covering. So moving on to the next set. Now this is a classical deep learning in contrast to a classical NLP. So let's say, if though I'm solving the same problem, what if I use a older methodology? What if I use a deep learning? Now you can see that in classical NLP, the picture under that particular box, we can see that there is a lot of work to be done manually. Let's say I need to tokenize, I need to get features, I also need to remove stop words, etc., etc., and then come up with a model. Again, in the model, I need to do proper feature generation, extraction, and then come with a model, and then come with an inference, and followed by the output. Now you can see a drastic change in what is happening behind deep learning. You can see that once I'm doing different sets of embedding, the deep learning does some of the really challenging work on its own and gives the outputs. So that is something deep learning has achieved, and we can see that that particular work has given good amount of accuracy in prediction as well. So, for example, let's say if I am working on this on the same problem of sentiment analysis using deep learning, whereas if I use the same problem to solve, approach using a classical or a traditional way of solving the problem, then there is good amount of feature selection and feature generation work which is left for the user to do. And hence the total it's not just about the time, but it also about the quality of work which is being done. Whereas deep learning does on its own, where it can actually select features on its own and keep the accuracy and keep the efficiency of the model at the highest level. Now this is something which I would tell that this is one of the key advantages. Now there are certain other advantages. Let's say the execution time. Now whatever model we build, at the end of the day, when we deploy it in a production kind of environment, or when you want to put it live, any user would expect the execution time to be really less, which means if I ask a question, I want the answer in the next maybe 5 seconds, not more than that, right? So if I'm using a classical NLP kind of method, obviously there are a lot of steps to be taken through, and hence it takes time for the bot, or it takes time for the machine to come up with an answer. Whereas the deep learning systems are quite fast enough, and they will be able to answer it really fast, and also the answers are quite good enough with respect to the expectations of the user. So that being said, now we have set what is exactly deep learning, and what's the difference between classical method of NLP and deep learning method in NLP. Now we are slightly going to go a bit deeper. Now these are the key components, I would say, in any deep learning mechanism. So typically this approach, these five boxes will tell you that what are the basic steps needs to be done. And I think this is something which is very important, and you can always see that this is somehow, at least 4 of these are in the picture of deep learning architecture. Now let us go one by one. I will tell you. There's also a code which I can actually show you, where we can see these are being used. But before that, I will quickly tell you what is exactly these 5 different things. Now let's say start with sequence length identification. Now let's say you have 5 different Twitter text, and in any case Twitter doesn't allow more than 140. Now let's say if you have some document which has varying length of text, obviously a prediction model or a deep learning network will want a standard size of matrix shape, right? So in order to have that, what we actually need to do is understand that what is the you know size of the matrix we need to pass. Let's say I'm limiting it to not more than 1,000 words, or maybe 100 words, or maybe 500 words. Now we need to understand that this sequence length identification has to have some basic understanding that, let's say if you have 1,000 rows and there are 2 rows which has 700 words, and all the other 998 rows has close to 500 words, then I would say we would go with 500 words as a maximum, because the rest of the 2 rows doesn't really take a great advantage. Now that is something which we need to understand. And of course there is no real deep learning involved in sequence length identification. You just understand what is the uh, sequence length I need to fix it, because that is the shape which will be going through every single step of the entire deep learning mechanism, and all the results will be based upon that. Now moving on to the second one hot encoding. I think this is typically let's say you encode all the categorical variables so that the machine understands that you are kind of giving a new numbers to it. It's not just passing your text variables directly, or passing whatever data we get. This applies even to image based works. In any of the image, we will always try to understand the pixel value, so we are not going to send any other value apart from the value of that particular pixel, so which represents the RGB data. So the three dimensional value. So that is what is typically encoding. Now followed by padding. So as I said, the deep learning mechanism expects some constant size of data, right? So let's say if there is a text document which has less than or 200 words, so what do I do for the remaining set of the data? So that is when you will pad the sequences with 0, representing that that's the end of the particular document. Again, if there is the next document which has varying amount of text, still it will hold, because we are padding to a maximum sequence length which we achieved in the first step. Now these top 3 steps are will define the shape of the matrix. Now, the fourth step, word embedding. So, word embedding is, typically assigning. It's like assigning weights for those words. Now, where you can get these embeddings, you can always get from where Stanford releases that particular data. So again, they release in specific shapes and sizes. Let's say 100 dimension, or 300 dimensional data. So obviously, it means that you need to set up the sequence length in matching with the word embedding data, right? You can always, it's available free in the internet, you can always go and download it. It's basically a a text file where each of the words are given some weights, and your embedding matrix, which is one of the key component of the deep learning mechanism, takes that input also, apart from the data which we send it. Now, word embedding obviously isn't a compulsory step. It's it's a step which will give you an edge over what we are trying to do, because these embedding values are derived out of huge corpuses which people work upon, and then come with the weight value. So obviously we can rely on it, but there are certain I would say hiccups coming in that space, because of executional issues, time, and using different shapes and stuff like that. Now the last one is the module design. Now what I mean by module design is let's say what kind of algorithms I need to use, and what kind of other steps which are need to be taken into account. So again, you can use different algorithms. As I said, LSTMs, GRUs are used in solving particularly text data. It is one of the popular techniques, but also there is a usage of convolution networks to solve the same problem. And you will find that CNNs are handling the data quite faster than your RNN networks. And you can add, obviously add a lot of dropouts in between. You can change the activation functions from sigmoid or ReLU networks, or any other linear or any other activation function. But again, some of the basic steps are going to be common. So that being said, I would say, until now we have seen the theoretical, description. Again, as I said, these are going to be some of the fundamental steps for anybody who is actually, going to try deep learning for the first, few times, or maybe slightly more than that. Now, yeah, coming to the case study, this is going to be a practical, mechanism which I'm trying to solve. So, as I said, I have used LSTM layers. I have also used, Keras to solve the same problem. Now, Keras is built on top of TensorFlow. Now they have made it very, very, user friendly. You don't find much of complexity in setting it up in your both of your Windows and Linux environment. So it's very easy to use, and you can always download it, install it through Python, and use it. And Keras also does support for R. Now the business problem, we are trying to predict the movie review scores using deep learning approach. Now this being the business problem, what's the solution we are trying to do here? So I have skipped the first two steps which we discussed here. Due to time constraints, I'm keeping it slightly lightweight. This IMDb dataset is always available. You can download it from the package which are available, followed by, again, sequence padding, where I try to fix the shape of the entire arc, data matrix. And then comes your neural network architecture, and followed by running the predictions. Now let's go step by step, by looking at the code. You can see that I started with importing libraries. I have also kept a threshold for myself. I have taken 5,000 words, and my review is about a length of 1500, which means I don't want to have more than 1500. Right now, that being said, I'm going to pad it at, at the max of 1500. So when anything which is more or less, it doesn't matter, because I'm going to kind of fix the sizes to 1500. And also followed by so this is again, there are two types of mechanisms put in Keras, where you have sequential mechanism and also a functional one. So typically all the functions work the same in both of the environment. The difference is sequential does more of a step by step, where you can see that there's always an addition of layer, whereas functional is not exactly taking step by step. So you give an output, you keep multiplying it, or it's typically a multiplication problem. You multiply by a huge matrix data by embedding vectors, or LSTM based waves, and then followed by a function which is to change it to the output variable. So these steps are going to be common. Now coming back to the code, you can see that I have fixed my embedding vector again. So what exactly embedding does? It's similar to imagine there's a high dimensional space where you try to convert your existing data into multidimensional data. So let's say if I stop after this particular line embedding, and just predict or through the output, you can see that you get a different set of matrix from what you actually passed. So in case you passed a matrix of 2 dimensions, you can see that this particular matrix is of 3 dimensional. Now the reason why you convert into 2 dimension to 3 dimension is that the basic expectations of LSTM is having a 3 dimensional vector data, not a 2 dimensional data. The same applies for your neural net convolution steps also. Now why do you actually do it? It's very simple. So now converting into a 2 dimensional data into 3 dimensional data gives you a vast flexibility, and also it gives you a better deeper look into the data actually, because now since you are adding more dimensions, um, you know it always gives the algorithm a better insight as to having a single dimension or a 2 dimensional data. To be very slightly simpler, let's say you are trying to predict the price of gasoline given the rupee value, let's say. So you just have 2 dimensions. Now let's say if you bring in a third variable, let's say you bring in the price of maybe gold, which is a third variable. Obviously you will understand that the addition of that particular new dimension, which is the price of gold, is that's where you have an edge, and you find that something interesting will come up. Now adding more dimensions, let's say uh, you know uh, let's talk about stock prices, or let's say if you are trying to add more of international and domestic parameters, or let's say bring in GDP, or bring in inflation rates, or bring in any other international daily exchange data, you can see that you will also get a better insight. And that's the whole point of converting into multi-dimensional data. So that will give you an edge of how actually we can do the problem, and hence those minor differences are getting noted down by the algorithm. Now followed by now with this step I'm completing the embedding mechanism. Again, I would say you might have to relook all these steps so that you get a better clarity. But honestly, all these are like a set of matrix multiplications. You input a 2 dimensional data, you convert into a 3 dimensional data, followed by giving an LSTM, and followed by having a dense network. Now just to give a slight introduction of what is LSTM. So long short term memory. So it is typically like our brain, where we remember some of the old data, and in relation to new happenings, we always remember that hey, this is something like we have experienced in the past, right? So that is the advantage of LSTM. It is essentially having a memory module inside it, and that's the one of the key advantages of having LSTM. Now your dense layer is it is nothing but a typical standard fully connected layer. It's nothing but having a new set of layer. So as such, it doesn't have a huge functionality compared to LSTM. But what it does is it downsizes the entire matrix into a point variable, because our expectation is just one output. We just want the review, right? We don't want multiple 3 dimensional data or a 2 dimensional. We just want one value which talks about the review of that particular movie. Now, this being said, this is a very, very simple architecture to start with. There is a real complex mechanism where we use a lot of layers. Let's say, for, I use a convolution layer followed by, pooling layer, and followed by, dropouts. So multiple, layers and multiple stacks of layers are available. In cases of, huge amount of NLP data, or in case of real image based approach, we always use different stacks of components. Either it can be sequential or it can be run parallel. So both ways, Keras does support. You can do single output, single input and multi output kind of models. You can always do multi input and single output. So all combinations are definitely possible. So but those are real complex mechanisms, and again, you need to have a real good reason of why you actually do it. You can always understand that, let's say if I am trying to build an algorithm where I want the prediction, but there is a completely two different sets of data. Let's say I want to relate Twitter data with my company sales data. So both are different. I won't be able to merge it, right? So what I would do is I will have a set of uh, you know uh, layers for handling Twitter data, and I will have a separate set of layers for handling my sales data or company data, and then I will be able to merge it. So once I merge it, the whole component of Twitter data and my sales data is being taken into account, and my algorithm does a better level of prediction. So which means I have a better hold on not just having Twitter data, but also on the company data. So that gives you an edge of having a standardized model, but also you can always include any data source which you typically want. So there is nothing like you just have to have one input and one output. No big deal. You can always have different sets of inputs and different sets of outputs. Typically, like your traditional machine learning model, where you can always combine any sets of data. Of course, you need to have a common key to merge it. So in this case, you can merge layers itself. So that gives you a huge advantage, and it always gives you a better prediction. So now this with this my case study is kind of over, but I would always want to re-revise a couple of minutes, and then we can get into a bigger discussion where we talk about our career path. We also talk about different answering questions. I can take more number of questions today. So to summarize, we saw the real advantage of having deep learning mechanism. We saw that what is the major difference between a classical NLP and problem and having a deep learning NLP problem. We also talked about embeddings. We talked about glow, and you can also have word to vec. I think word to vec is some of the common mechanisms which people might have done. And then comes your prediction of that particular output. So there's a whole chunk of manual work kind of automated by using deep learning mechanisms. Again, the efficiency of deep learning mechanisms depends on having the right set of stackings and right set of layers, where we can keep control the number of parameters being used. Actually, having huge amount of parameter will lead to, again, the older problem of overfitting. So it's always good to have the right set of parameters rather than having huge set of parameters. Now, to revise on the components, we talked about 5 different components. Your sequence length identification. We also talked about what is one hot encoding. We talked about padding, and this particular alignment, or the way these 5 boxes are available, it's actually step by step. So you can always see that you do this and then move to the next one and the next one. And again, word embedding is one of the key components, where it's not a mandatory step, as I said, but yes, it always gives you a better handle over the text data which you use. This is particularly for uh, NLP space, followed by your deep neural network module design or architecture, or whatever we call. Now, one of the key challenges which we discussed, again, we might face in sequence lengths, word embeddings. We also talked about how to actually address a particular sequence, or how to assign a sequence length. And then we talked about some of the common small issues in word embedding. So make sure whenever you use word embedding, you have the right set of dimensions. Whatever is in the embedding document dimension should be in your actual layer dimension. So both these guys should match, because again, as I said, both these are a set of matrices. So the expectations is that if you use 100 dimension word embedding, it is assumed that you will have a 100 dimensional input, which means your input length shouldn't be changing from that particular value. There is also 300 and 500. So these are collectively done by a great set of researchers, and they are being released periodically. You can always go to GitHub and find that particular text. You can download it and use it. Yeah, and we saw about a small case study of movie review prediction using deep neural networks. And we also talked about one of the tools which I have used here. We talked about Keras, and then a bit on the code. So we saw that where we are trying to use padding, where we are actually use embedding. We also talk slightly deeper into what is exactly embedding and what are the advantages, followed by LSTM and dense neural networks. So now with this I'm kind of ending a technical session. So in the next half an hour or so, we will have two different sets of discussions. One, I will talk about the career path, and two, I will talk about what kind of questions are being put out and how I can answer. So these are the next half an hour happenings. Fine. So moving on to the next set of discussions. So now coming to the business of having a career path. So some of my previous attendees might have seen this this particular slide. I'm still going with the same. The reason I'm going to have the same set of structure is that as such, just because of deep learning or not, not having deep learning doesn't change this high level structure. So as I said, there on a very high level, I would say there are three different sets of roles. Your one being the completely functional, where you definitely require the knowledge of analytics or whatever recent happenings are happening behind the field. The second one, techno functional, where you would actually deal, I would say 75% technical, or maybe 70% technical and 30% of functional role. And the last win being completely technical role. So thank you all for participating. Have a great day.